All right, everybody, so we are here in Shelbyville, Tennessee during the middle of a rainstorm. So if there's any background noise, I apologize up front, but you know, that's the forces of nature. So
this is how it works.
Here with Nick, owner of Arion Aircraft in Jabiru, USA. And we went through a whole bunch of shop tour, hangar tour, what's in the hangar, talked to Jabiru engines, and I want to sit down and just kind of talk industry with Nick, being that he's in the industry as a manufacturer, as a parts engine importer, works in avionics, and is also a test pilot. So I want to kind of talk on those different subjects today. So sure. Nick, quickly introduce yourself and where we're at and what we're doing here.
Okay. So Nick Otterback. This is Arion Aircraft. We're Middle Tennessee, Shelbyville to be exact. KSYI is the airport identifier, and this building is one of two buildings we have that we operate out of. The one next door is our service facility. We do annuals and overhauls and things, and this building here we're in right now is our production building. Although you don't really produce experimental aircraft, you build assist them, but this is what we call our production building.
Sure. So you do manufacture the Arion aircraft?
Yes.
Okay, and you've been doing that for several years, so let's talk on that as far as the industry. I talked to some people in the past that are also manufacturers, and we've kind of come through COVID, as an industry, aviation and so forth. We've come through a bit of inflation. We're still doing okay. Yep. I just want to have you speak to that, I guess, as far as like, I know we've got cycles of things that come and go with industry, but for some reason it almost seems like, correct me if I'm wrong, that aviation is almost like recession proof, or like it just keeps going.
Yeah, our sales during COVID and our sales coming out of COVID and now aren't any worse off or any better than they were before. They've stayed pretty steady.
Now there was a spike. I think everybody saw a spike during COVID because people were at home.
Yes.
And they're like, let me do my bucket list now.
We especially did with engines.
Okay. Other than that, though.
Airframes, but engines, because guys had planes, they were getting done quicker and they wanted engines. So,
right.
But yeah, there was a little bit of a spike coming out of that. But we've been pretty steady through it and out of it. And you know, our prices have gone up, but we have to. You know, our suppliers, their prices go up, so it's unfortunate that we have to do that. But other than that, no, we've done pretty good.
Because I remember thinking when COVID hit, and then now inflation, like, I picked a really bad industry to get into or something, right? Because like, what am I going to do now? But no, like during COVID, we saw a spike. I saw a spike in views. You all saw a spike in orders, and like it just was flourishing. So it just, I think, even in hard times, this is fun. Yes. And it keeps your mind busy, and it's challenging. So I think maybe those are some of the drivers for aviation being successful.
I think it is, and I think people, you know, my wife wouldn't agree that it's an investment in an airplane, but you know, either your money makes money in the stock market, or you can pull it out and build an airplane, and it's an investment. And so you want to do something with it. You know, you want to do something with that. And so I think that's part of it too, is that guys have it and they want to use it, and this is just another way of investing it as an airplane. So.
Now through that, and there were some changes and transition in our industry, it seemed like people were bringing more things back in-house. Did you see that as far as like third-party manufacturers, suppliers? Did you have to bring things back home to make, not only control quality, but just because of supply chain?
Supply, yes, a little bit. Ours, I mean, we've always done all of our manufacturing, although we don't do it under this roof. We don't pull it from overseas. You know, our major composite suppliers in Kentucky. Okay. Our major metal supplier for our welded and CNC parts is in Idaho. So we've always been really steady with those companies. We've been with them a very long time, and we never had any quality control issues with them. Now, some of the places we were getting other parts, yes, we had to source different parts, do some of the stuff ourselves that we normally wouldn't do. But now, again, it's kind of funny, we're kind of coming out of it. Like, we were doing panels in-house really heavily because we couldn't get panels done anywhere. We couldn't find anybody reliable. But we've now found some other places to do panels again for us, so we can kind of start
push that off your plate again.
Back off our plate and concentrate on airplanes and engines and stuff. So.
Nice. Okay.
Because it was a problem. We talked earlier. I've myself wired several panels myself just because we had to. The guys in the shop can't do it. our avionics tech retired. We couldn't find anybody to do them, and so not something we want to be doing, but something we had to do.
Sure.
And just to make sure it got done and the quality was there for our customers. But now we're kind of starting to get to push it off again. So
yeah. And the reason I wanted to bring this up, sort of, is that there's been a lot of talk or concern that, you know, if I buy this kit or this aircraft or this engine, are they going to be around in a couple years to support what I just bought, right? And for the most part, I would say that you're pretty secure. Now, we're talking about companies that have been around for more than a decade.
Right.
There are some companies that you might see at an air show just pop up. Of course, I mean, who knows? That's a wild card, right? I mean, they're brand new, and that's up to you as far as where you want to put your money as far as risk levels. But I just want to bring that up.
Aviation.
Huh?
Avoid aviation.
Well, moderate risk to where you can, right?
No, we love it. We wouldn't do it otherwise. But
yeah. So I just want to bring that up with Nick and discuss that area of it. Moving to a kind of different subject, but within manufacturing, you not only manufacture, but you have the unique opportunity to do builder assist and final completions, which gives opportunity for you to get your butt in the seat. And a couple things. One, you get behind your actual airframe that you built, you designed
yes.
and built,
yep.
and then the engine that you primarily use, a lot of these, is the Jabiru.
Yes.
So your butt is in the seat behind the airframe and engine, and then further, you do a lot of the panels. So you're behind the wiring, and you're the one looking for the smoke.
Yeah. Yeah. So
let's Nick is a mechanical engineer.
Yes.
Right, and then kind of self-taught aeronautical.
Yeah, right.
Yeah.
Right.
So there's that thinking and mentality, but he gets the opportunity to test fly. I want to kind of go through what it's like for him to. What is your process? Because to me, that is the scariest thing out of all this. And here I am promoting aviation, but when you finally get it done, get it out to the tarmac, start it up, and go fly, you have kind of like a ritual that you do in testing things over the airport. Yeah. But talk to me, like, what is that like? And then emotionally, which is probably no emotion, but so, what's that like?
It's exciting to do first flights, exciting to fly planes you built. We've been doing it for 20 years now, and I don't get complacent. I don't get jaded over it because we do it so much. But when you build an airplane from a crate and then you build the panel and stick it in there and you go out there and you go, I've got really good guys that work for me. I mean, like here, we have really good people. I trust all of them literally with my life. That I know when we finish a plane and I get in the plane, it's going to be correct.
Solid.
It's going to be a good airplane. Yeah. I'm not worried about some flight control being reversed or some other stuff. But I know I'm going to have a quality airplane, a safe aircraft I'm going to get into. Now, when I'm going to go do my first flight, you know, and I don't even know how many I've done. I can't even count.
Dynon Avionics at Dynon.com, offering everything from state-of-the-art glass cockpit options to advanced control modules that power and control your entire aircraft. Gratia Aero Group at GratiaAero.com, proudly representing these best-in-class brands for experimental general aviation. Sherwings, BD Aviation, and MW Fly. Visit us online at ExperimentalAircraftChannel.com for all things DIY aviation. And consider supporting us on our Patreon page to help us bring you more original aviation content.
Every aircraft that's built here, I fly. Every one of them is the first flight I'm in it. And it could be a Lightning, it could be an RV-14. You know, we don't know. Could be a Jabiru. But anyways, I will spend probably the good part of a day or two going through the aircraft. Even though myself and the DAR and the builder have gone through the aircraft, I've looked at the airplane 100 times through the process that's been here. But I'll take myself by myself. And that's the other key thing for me is I don't want any distractions. I don't want the phones ringing for tech calls, you know, so I'm doing this in the morning. You know, I don't want my guys, and they know not to bug me. But when I start to look at an airplane for first flight, I'm going through every nut and bolt. I'm going mainly really through all the flight controls. You know, flight controls are a big thing. The panel falls off, and you know, it's not going to, but
fly it to the ground.
Yeah, you know, inspection panels, whatever, screws are loose. But flight controls, main flight controls, the engine is running correctly, things like that. I'm looking through all that stuff. And when I'm really good and convinced that all of that's going to work for me, then the first flight for me isn't Tuesday or Tuesday next week or Wednesday. The first flight is going to happen organically when I am ready to do it. So, you know,
you don't schedule that at all.
No, and people say, "Oh, you're going to do the first flight today. I want to be there." No, it's going to happen. And what'll happen when I do it, I'll usually tell one of my guys, "Hey, I'm going to fly that plane," and I just tell them when I go out, and then they leave me alone. They know I'm out there. They're not while I'm flying. They got a handheld radio, so they can listen if I need something, not that they can do anything about it. But you know, too many times I think with experimental aircraft built at home and things like that, people get pushed into that. When are you going to finish the plane? When are you going to fly the plane? And
get their itis.
Yeah, I got to go fly it now. Well, no, you don't have to fly it now. Nothing says you have to fly it now, and you know, nothing says we have to fly it today. So, you know, when the weather's right, when the wind is right, when everything's good, it'll get pushed out the door and off I'll go. You know, my first flights are always, you know, I've already run it on the ground a couple times. You know, the engine is set, the engine parameters are good. I don't do crow hops. That's one thing I do not do. I know people do them, and that's just my opinion. But if, you know, when you roll out on that runway and you put foul power in there, if it's making power and the oil pressure is good, you're gone. You know, you think about it this way, it's a new airplane. Even though this is an RV-14 and there's X amount of thousand more of them out there, this is a completely different airplane than the guy next door, right? Everything's different about it. So you're going to pop off the ground in a plane that you've never flown before, or maybe you have, and you think that 5 seconds later you're going to try to land that thing out of an uncontrolled approach or an uncontrolled, right? That's because basically that's what it is. We pop up, oh, who would fly to land? That's not smart. That's really dangerous, actually, in my opinion. So
you want to learn how the airplane feels and reacts before you try to land it again.
Yeah, no, obviously, if something's severely wrong, yeah, you do what you got to do to get it on the ground. Right. And we've had a few of those cases, and it was more like an electrical shutdown or something like that. But it wasn't an issue where the plane was so far out of rig it had to come back on the ground. So, you know, you power up, you take off, and if you're in the air and it's solid and it's feeling good, you're going. You're going to go. You're not coming back down right now.
So the adage that I've heard in the past is like, only fly as high as you're willing to fall. Don't do that.
Because in an airplane it doesn't matter. Because if you fall 50
if you're expecting to fall, then your wings are going to fall off, and you should have figured that out beforehand.
Before you took off. Yeah, I mean, the airplane should be, for first flights or any kind of test flying, it should be ready to fly anywhere, you know. I mean, not 500 miles down the road, but you know,
within reason, with a little bit of trim here, or a little bit of.
Yeah, you shouldn't be like, oh, I'm just going to go fly at 50 feet down the runway and land because I think something might fall off. No, you should have looked at it already. You should have really gone through the airplane. So all of my flights, I take off. I mean, and I'll even go far as making sure there's not a lot of traffic. You know, there's stuff's kind of calmed down, and I climb up and I stay, you know, within 2 or 3 miles of the airport. I mean, I stay within gliding distance because you don't know. If, you know, obviously you've done fuel flow tests, you've done all these tests, you know, everything says it should run, but you don't know.
Yeah.
You know, you just don't know. So you take off and you get up 3,000, 4,000, 5,000 feet as high as you can go comfortably. You know, I don't need to be up at 10,000 feet, but get up there and circle the airport. And mainly on first flights, I'm just looking at temperatures and pressures. You know, I'm going to fly the plane a little bit. You know, check out the rudder, check out the roll. I don't even stall the aircraft on first flights, but I will slow them down. Do a flap deployment, you know, slow the plane down to approach speed and a little bit below it to kind of feel what it feels like as it's going to settle onto a runway. But no, I don't go up and do a stall or something like that on the first flight. That's going to come, you know, that's going to come in the second.
One step at a time.
Yeah, yeah. So go up, fly it around, feel it out, handle it. If it feels good, you know, and the temperatures are all good, you know, the first flight might be 45 minutes, but usually not longer than that. And then you slowly make your way down to the runway as if at any time that engine's going to quit.
Sure.
And I know that's probably like old school wives' tales from airplanes that were built 70 years ago. You know, the engine's going to quit at any time. And these are reliable aircraft engines. They're going to run. Most of the time they're going to run. So if it might quit, it's going to be some mistake you've made in the fuel system or electrical or something. You know, you don't know.
But it hasn't earned your trust yet, nor should it.
Exactly. That's right. So you fly it. Mostly a powered off approach as I'm coming in and keep it tight, and I got 6,000 feet here, so if I use up half the runway before I land, who cares?
Yeah.
You know? So that's first flights for me is you know, I fly it when the plane is ready, when I'm ready, mainly, you know, and when the situation allows it. There's no reason to push them.
So I asked you earlier, you know, that question, like, what do you do to prepare yourself emotionally? And I believe you kind of already start that ahead of time by saying, I've already checked out the plane. I'm not going to schedule a date.
No.
That is starting the emotional process because you're not building yourself up to something.
For me, I don't give myself time to psych myself out.
Okay.
Like, I think if I sat there and dwelled on it and said, oh, tomorrow morning I'm flying this airplane. I'm going to fly it tomorrow morning. So all night you're thinking about it. You get up in the morning, you're having your coffee, you're thinking about it. No, just go through your normal day, go through what you're doing. And maybe that's easier because we're a manufacturer. I don't know. But, you know, I just let it happen. Oh, yep, it's good to go. I'm going to go. And I haven't given myself enough time to worry about it, think deep, like, oh, God, if the canopy opens, what happens? Or if the door,
that makes sense.
The oil door pops up.
It's kind of like when you do your first solo, like you don't know exactly when you're doing your first solo.
Out, says have fun, and you're like, okay, I guess I'll go do it.
Yeah.
And at that point, you're just on what you learned or what you were trained to do. So
that makes sense.
So that's kind of like first flights for me. I don't give myself enough time to psych out about it. It's going to happen today, and you go. So I don't know.
That makes sense.
It works for me, anyways. You know, it might not work for the next person, but.
And when you go through, just kind of the essentials, like you said, is temperatures and pressures.
Yeah.
Which basically is making sure it's not overheating, so you have to go down, or losing pressure, which is fuel, so you're going to go down.
Yeah. I mean, the engine's got to run, so it's got to have fuel, and the oil pressure's got to stay up or whatever. You don't want to overheat it, you know, that kind of stuff. I don't even switch tanks. Like, if I took off on the left tank, if it's a low wing, it's staying there.
There's no need to at that point.
I'm not going to switch. And when I do a second flight, I'm going to take off on that first tank that I used, you know, because I know that system works. And I know the other one works on the ground. I've done fuel flow tests and stuff, but I'll switch tanks in air because, you know, the places where you're going to do damage to yourself or the plane is takeoff and landing, right?
Yeah.
And there's no reason to have engines quitting takeoff or landing or whatever. So get up over the airport, switch tanks, turn the pumps on, and watch what happens. At least up there you have time to think about it, you know, instead of 50 feet where the engine quits because you wanted to fly on the right tank today instead of the left tank. So
makes sense.
Just kind of things I do, you know. It's not everybody's cup of tea, but that's what I find works for me.
So kind of changing topics again here, being that you've got, and your staff, of course, a lot of experience with so many aircraft that have come through here to completion, and also being, well, you've done a good mix. You've done from like a kit from start to finish to 90% done, 90% to go. Other than this is a full-time job for you and for your staff, what would you say, because you've done some personal projects, is a good tip or hint to staying engaged in your project to be able to get it done in not 10 years, but like say 2 or 3 years? What is that? I'm at the 10-year market. Everybody, I'm at 10 years.
Yeah.
So that has not been true construction time. That's been job changes, bootstrapping a business, having 3 kids. I say and I joke that my wife has manufactured 3 kids, and I haven't even manufactured 1 airplane yet, right? But that's just life. So what do you think?
My third kid was a race with the RV6.
Was it?
Another story.
Your third kid was a race with the RV6.
The RV6 that I built, yeah, because
you knew when that one arrived, you're going to be busy for a while.
So she was pregnant with the third one, and then I made the choice to buy an RV6 project. And
in the middle of it.
Well, you better have the plane done before the baby comes. She goes, "What's the baby?" It's 3, you know. I'm like, oh crap. And I have 5
there's
now,
priorities here. Like I remember when number 3 was coming, I was doing a rush to build out a bathroom which had a shower and no tub because we just moved, to have a tub so we can wash a baby, and he's over here buying airplanes.
So I got the plane done, and the plane was built and finished in August, and he was born in December, so I beat him.
So what he's saying is, if you want to get your airplane done, is to have a kid. Have another child.
There you go. It worked for me.
There you go.
I don't know if it worked.
A timer of 9 or 10 months.
And I have 5, so I wouldn't, suggest that. But unless you're really crazy. But
I'll have to talk to my wife about that.
Yeah,
I need to get the airplane done. Let's have a baby.
It's kind of plateaus, like 1 or 2, and then once you get to 3, so it doesn't matter how many you have to have that.
It's old hat after that.
Yeah, it is. It's all the same stuff. So.
Other than having children, what's a good tip to get into your aircraft finished?
I would say, and again, it's hard for everybody, but I would say try to do something every day if you can. Even if it's, I'm going to go down and mark a center line and bend 1 piece of sheet metal, and try to do things to keep yourself excited about it. I know that's really hard to do, but like you're building a 750, watch some STOL videos and stuff.
Yeah.
You go to all those things. But for somebody who's at home building one, or you're building a cross-country plane, go see about places you want to go in this plane, and so it kind of keeps you energized about the project. Because the planes that we build, like I would say better than half our business in the build program, there's airplanes that have been through 3 or 4 flight builders, and it's people who just got bored with the project. Like they were super excited at some point in time to buy a plane kit and build it in their own house. But then they just, oh, well, I had to build a garage and I had to do this and then I had to put in a toilet and oh, somebody got married and they just, wasn't exciting anymore. So they want to do something else. So, you know, probably stay excited about the project somehow for yourself. And try to do a little, like at least one thing a day, you know, is what, that sounds so stupid, but maybe you go downstairs and look at the plans for a few minutes and pick out your next project or something, because that just kind of keeps you excited, you know, what you're going to do. And it might make 10 years, it might take 20, who cares? You know, I always laugh when I look at the back of what our members are building in EA, you know, the EA magazine. Yeah. And, I 25 years building my Steen Skybolt. I'm like, oh my God, I don't have that kind of tenacity, but cool, you know. So, you know, something every day and stay excited. That's what I would do. Okay.
And again, I know I'm kind of cutting corners here to sharp different topics here, but
we can do it.
Something that I can do it. I can do it. Something that it keeps like coming up in the back of my mind is aircraft that are built, and when you go to register, apparently as the builder, you are also kind of the manufacturer, almost as if you're the engineer too, but you're not. You're buying a kit, and it has certain parameters. But there's a lot of people I've heard that are kind of self-registering at certain weights, and I wanted to ask you, as a engineer and as a manufacturer, the ripple effect of doing that, and if you are to do that, what kind of flight testing you should do or whatnot to be able to do that safely, right? Let's say that, let's use the 1320 pounds, you know, as an example, and somebody decides that they're going to register at like 1,500 or 1,600 pounds. What is the ripple effect in engineering that
I think there's
effects?
Again, that's a small step, but you know, anything over the design gross of the aircraft can, you know, the builder at home, sure, okay, I'm going to go from 1320 to 1500 or 1520. You know, you can go out there and do your weight and balance. You can figure out how to put that much weight in there and do flight testing, do stall testing. They can do all that kind of stuff. But the things that you don't think about are like gust loads and turbulence and landing loads when you accidentally drop that airplane in from 3 feet off the ground. You know, the manufacturer, the designer of that aircraft just said, okay, this is the gross weight of the plane. And, you know, when we were doing drop testing and things like that on our SLSAs, we had weights and loads and stuff and heights we had to drop them at. And so now, if you increase that weight from that height, you have different loads, right, when the thing hits the ground. So those are things that a home builder really can't do. You're literally a test pilot and, you know, kind of you're a test pilot and an engineer for something, you know, you don't know. No, people do it all the time. They're safe. I think sometimes they get away with it, you know, on some projects. But there are a lot of unknowns with that aircraft that you can't test for. You're just going to have to, well, you know, the axle's not going to snap off when I accidentally drop it in from 2 feet, or, wow, that was a really bad bump. Hopefully the next one doesn't rip a flight control off the airplane. You know, when I'm flying around at 300 pounds over gross, you know, that's the big thing. So
stall speeds, and how it's going to react, or what's going to bend when you do a hard landing, and what about like
that's just a few little things.
But like to me, I think it's a big one is not only stall but spin, right?
Yeah. Well, spin.
That's a whole other.
Yeah, and I think that's something that. I mean, obviously, I spin airplanes all the time and aerobatics and stuff like that. But when you talk about a new design or a design, you say, well, I'm going to put more weight in it. You know, where is that weight? You know, or how are you putting that weight in there? Is there more fuel in it? Obviously, there's not. It's the tanks are the same size, right? So everything's, you know, in the cockpit or whatever. All your weight's going to be there. And how does that affect the CG? You know, if the CG is in a range, it should spin correctly, right? But you don't know. You don't know how it's going to enter and exit and stuff like that.
Yeah.
And so I just think there's a lot of unknowns that you can sort through that stuff with flight testing, the easy stuff, you know, climb rates and VY, VX, stall speeds, landing speeds are different, takeoff speeds are different. But it's all the other things, like I said, about like gust loads and gust factors, landing loads. That's load testing. Now, if you want to load test it, well, go for it.
Yeah.
But most people don't do that. They're just going to say, well, I'm going to fly it 400 pounds heavier.
And the reason I bring this up, other than I've been hearing this, is that just like if we think back to like the days of all of us, flying certified aircraft, and let's say like a Cessna, I don't know exactly the empty weight is like 1150 or something like that, right? But if you were to weigh it 20 years later or whatever, the airplanes gain weight, whether it's the dirt that gets stuck in the carpet or whatever, they all gain weight. So you reweigh it, suddenly you're at 1175, and you're doing your math, and all of a sudden your empty isn't your empty. Well, as builders, and more options that we have between bigger engines, more avionics, all the options, all of a sudden, from the original design of the manufacturer, you were thinking this. Now these new options come out, so they are also getting heavier. Right? And the people they're building these are thinking, well, I'll just fudge the number a little bit or fly fat. Right? So I just want to, as an engineer and as a manufacturer, kind of speak to that as you have. Me, the spin thing is a thing because I think back to when I owned a Grumman Yankee, I think it was placarded no spins, and I didn't really understand the why behind it, but a lot of it has to do with the rudder and the gyroscopic forces that get going when you get into a spin. And if a rudder's not big enough, A, you're not going to have enough authority. Two, but then the gyroscopic forces.
Correct. That's loads and weights and CGs and stuff like that. I mean, also with some of those airplanes, they don't want you to spin them because they probably won't recover in certain configurations. Plus with certified aircraft, the spin testing is completely different than making spin certified. Like 152s, 172s are spin certified. You can go to spin those all day long. But there are certain aircraft, that won't recover from spins in certain configurations. So either A, they put parachutes on them. Okay, they do. Seriously, that's how they get. Well, they do, and there's plenty of documentation about that. So, or without naming names. Otherwise, they go ahead and they just say, well, no spins, and that covers liabilities and things like that. So, but I mean, spins is just a small thing about it. There's a lot of other things that I would be more worried about than a spin, than with higher gross weights than that. There's a lot of other aero elasticity issues and things going on there where things flex and do things and stuff like that.
Well, I mean, this is, to me, and this is why it's such an interest to me, and probably many of you too, is that this is the ultimate version of hot rodding.
Oh yeah.
Right? I mean, I grew up with an old Camaro in my garage and rebuilt the engine and stuff. This is the ultimate hot rod project where you get to build pretty much all of it if you want, to whatever level you want to, and then go fly and put holes in the sky. But
you die if a wing falls off.
Yeah, there's a limit to the hot rod.
Camaro, it's okay. You pull over and have a tow truck. So that's, I think, where it is the ultimate. I mean, and we do different engines, bigger engines, things within range and stuff like that. But at some point, you have to trust the people that were smarter than you and kind of play within the box, that you're given. I think, anyways, not smarter than you, but smarter than there's people that are, leaps and bounds smarter than I am. So, but plenty of. And so that's why I said I just have to trust that that's what they said that I should do. And like my RV6 has got an aerobatic gross. I can go, well, I'm going to fly it. No, Dick Van Grunsen said this is the aerobatic gross, and that's what I'm flying it under. If I want to do aerobatics in it. I don't question that, and I don't go out and think, well, maybe I can go a little fatter and do this or that. And they've decided that's what it's supposed to be, and so I don't live by all the rules, but that's one of the ones I do live by. I like to kind of play by those rules. So.
As long as the maths.
Yeah.
When the math doesn't math.
Then it's bad.
Yeah.
So, I mean, I don't know. I mean, I completely agree with you. That's the hot rodding of the air. It's cool to paint jobs and upholstery and, different props and different engines and do cool things. But there are just some things you just got to play within the box, I think.